Hi students, thank you for making sure you're working hard and focusing even though I'm not there today and listening to the sub. So we're going to work through this together, and you can use this video to help you complete it. So first things first, make sure you write your name on the front of the worksheet so that when it's collected, we know it's yours. So today we're going to talk about scale drawings and models. So we're going to go ahead and move on to the first page and just talk about what scale drawings are and how to create a scale model of a picture or an actual object. So if you look at a map, or if you create a piece of clothing, or if you look at instructions for making furniture, then you've most likely used a scale drawing. So what is a scale drawing or a scale model? So think about it and see if you can write your own definition of a scale drawing, or think of your own definition of a scale drawing before I share it with you. Okay, so what did you think was the definition of a scale drawing or a scale model? Okay, so a scale drawing or a scale model is hopefully something that you shared or that came to your mind, is similar to the actual definition of the term. So we're going to go ahead and write down what it actually is. It's a representation of an actual object or place that has been scaled according to a factor multiplied by the length of the original object. Okay? So, obviously, when you're building furniture and you're using the instructions, right? The size of the table that you are putting together is not the actual size on the instructions. That's a smaller version. But they have created what's called a scale drawing. That picture on the instructions is, if you enlarge it, makes the actual size table that you're working with. It's a scale model of the actual table that you're putting together. So here are times when you would use a scale drawing. Maybe you're drawing plans for a house or a building, or making a model airplane, or when you're using a map, or when you're putting together a barbecue. There's lots of times when you would use a scale drawing because you don't necessarily want to work with the size of the full thing yet. You need to have a plan. You need to have some sort of scale drawing to deal with before you work with the huge size of the actual thing. So now it's your turn to come up with a list of jobs that would use a scale drawing or a model replica. So take a few minutes, pause this video, and think of some jobs or activities that would require the use of a scale drawing or a model replica, and write them down here. Alright, so hopefully you were able to think of some jobs that would use a scale drawing or a model replica. And we're able to write down some examples. One example that I can think of is to create a mural. Remember the mural that you have murals all over Vinedale, right? The artist could sketch that out on paper first in a scale model, and then paint the mural on the wall of Vinedale itself. So that's one example I could think of. Okay. So now we're going to do some review. Could I maybe get somebody to read out loud? Or go ahead and read this to yourself first. So pause the video and read this. And then we'll go over what this means. All right. So proportional reasoning. So a proportion is a statement that compares two rates or two ratios. Well, what is a ratio? First of all. So we reviewed ratio a couple of days ago, but go ahead and reread the definition of a ratio. So here is a ratio, right? Is a comparison between two numbers with the same units. So for example, if we are at the mall and I have, 10 shirts and you have 3 shirts, then the ratio of our shirts are 10 to 3. So for example, okay. A ratio can be written as a fraction, right? It can also be written as a ratio with a colon. You see the colon? Or we could also write it with a word. 10 to, 10 to 3. So these are different ways we can write a ratio. So make sure you pause the video, have that all written down. All right. Now, a rate is a comparison between two numbers with different units. So an example would be, let's say I'm driving on the highway at 60 miles per hour. 60 miles per hour. That's two different units going on. So for example, 60 miles per 1 hour. I have two units, miles and hours, right? What if I'm eating 10 sandwiches in 2 days? That's a lot of sandwiches. But if I eat 10 sandwiches in 2 days, that's another rate. Two different units, sandwiches and days. Okay. Okay. I'm going to go ahead and have you ignore this part. Just cross it out. We don't need this. And skip to where it says scale factor. So go ahead and read this and see if you can fill in the missing word. See if you can fill in the missing word. Scale factor is the number the dimensions are blank by to give the dimensions of the other object. See if you can remember what goes in that missing blank. What do you do with the scale factor to make the new object? All right. So the answer here is scale factor is the number the dimensions are multiplied by. Did you get it right? It's okay if you didn't. We're reviewing. But you take your scale factor is the number that you multiply by to get the dimensions of the other object. And remember, we reviewed this yesterday, enlargements and reductions. Do you remember what we have to scale factor needs, or what the scale factor needs to be in order for something to be an enlargement or a reduction? So what does a scale factor need to be for it to be an enlargement? And what does a scale factor need to be in order for it to be a reduction? All right, so hopefully you were able to say that in order for it to be an enlargement, your scale factor is larger than 1. And for it to be a reduction, your scale factor has to be less than 1. So hopefully you were able to remember that from yesterday. What questions do we have about this? Okay, so now I need everybody to go ahead and grab a ruler. So don't crowd the back of the room. But once you get to this part, I need you all to grab a ruler. Grab a ruler. So pause the video here, grab yourselves a ruler. Okay, now that you have a ruler, you're going to take your ruler and you're going to measure the dimensions of this object in centimeters, okay? So that means what you're going to do is you're going to take your ruler and you're going to take it centimeter side and you're going to go ahead and measure the sides of this box. So first you're going to measure this side. And for me, the measurement of my box is about 4, oh sorry, you got to start at 0. So it looks like it's at about 5 centimeters. So it starts at 0, ends at 5. So we have that the dimension of that part is 5 centimeters. So I'm going to write down that this is 5 centimeters. Then I'm going to go ahead and rotate my ruler. And I'm going to measure the other direction, dimensions. So I'm going to measure this part. It looks like it's about 2.5 centimeters. So you see, starts at 0, ends at around 2.5. So it looks like these sides are 2.5 centimeters about. So the sides are 2.5 centimeters. So you go ahead and measure the sides of this box. You do that with your ruler in centimeters. Pause this video and find the sides of this box. Okay, once you have the sides of this box, you're going to go ahead and do the same thing to the larger box. So after you have found the sides of the small box, you're going to go ahead and find the sides of the big box. So again, take your ruler, find the sides of the big box. So pause the video, do the same thing to the big box. Okay, once you've found the dimensions of the new box, I'd like for you to find the scale factor. How did I get from the small box to the big box? What did I multiply by to get from the small box to the big box? So figure out how I went from the small box to the big box. So pause the video and see if you can figure out my scale factor to go from the small box to the big box. All right, for me, my scale factor was 2. I went from 5 centimeters to 10 centimeters here, 2.5 centimeters to 5 centimeters here. So my scale factor was 2. All right, let's move on to example number 2. This one is slightly different. This time, let's go ahead and read the problem together. The ratio of the length to the width of a rectangle is 5:3. So I have a rectangle and I want to draw a picture of what this looks like. So you kind of have an idea of what's going on. Basically, what this is saying is I have a rectangle and the length is 5, or the ratio of the length is 5, and the width is 3. So this is what my rectangle looks like. Then I took this rectangle and I have enlarged it so that I have a new rectangle. The rectangle is 24 centimeters wide. So I have a new rectangle here. This one is 24 centimeters wide. But I do not know how long it is. So this is an X because I do not know what it is. I'm going to use an X to represent the unknown quantity. So we'd like to know how long the length of this rectangle is. So if I dilate from 5 to 3 to X to 24, how do you think we can do that? So my first question to you is, how do we go from 3 to 24? So think about it. How do I go from 3 to 24? All right. So yes, indeed, what you do is 3 times 8. 3 times 8 gives you 24. So if we do 3 times 8, that gives us 24. So if I multiply 3 times 8, well, what do I have to do to the 5 to get X? What do you think I have to do? Well, if I multiply 3 by 8 to get my width, I also have to multiply 5 times 8 to get my length. So then I have to do 5 times 8. And what does that give me? Well, that gives me 40. 40. So I know that the length of this rectangle is 40 units. Okay? So there's my missing length. All right, so what you need to do to one of the sides, you also have to do to the other side. So this is kind of what we're going to do with the rest of these. So your goal is to figure out how to get from here to here. Now, I'm multiplying. Yes, multiplying. Do you remember the opposite of multiplication? That's right. The opposite of multiplication is division. So one way to figure out the scale factor from these numbers is to divide. So I'm like, I don't know, 8 times whatever is 160. I have no idea. I don't know 8 times what is 168. I don't know what that is. So what I'm going to do is instead I'm going to go the opposite direction, and I'm going to do 168 divided by 8. So I can figure out the scale factor. So I'm going to write it here. To figure out scale factor, you can divide because division is the opposite of multiplication. So to figure out my scale factor from 8 to 168, because I don't know how to go from here to here. No clue, not at all. I'm going to go ahead and do 168 divided by 8. This is when your long division is useful, right? We did long division, we practiced long division so that we can use it for these kinds of occasion. So I'm going to go ahead and do the first one as an example, 168 divided by 8. Okay, 8 doesn't go into 1, but does 8 go into 16? Yes, it goes in 2 times. 2 times 8 is 16, so subtract 16, that's 0, bring down 8. 8 divided by 8 is 1. 1 times 8 is 8. 0. And my scale factor is 21. So now I know what my scale factor is. My scale factor is 21. That means I go 8 times 21 to get 168 times 21. So guess what I have to do to the 3? That's right. I also have to times it by 21. So 21 times 3 . 1 times 3 is 3. 2 times 3 is 6. So x is 63. So this is your goal for the rest of these problems, okay? Your goal is to figure out what x is by first dividing to find the scale factor. I don't know how to get from 13 to 91. I have no clue. So what I can do is I can do my long division, 91 divided by 13. And then I'm going to go ahead and find my scale factor, and then I can figure out, okay, I can figure out how to go from one to the other, okay? So go ahead and see if you can do the rest of these. For number 2, you may use a calculator. For number 2. And your goal is to get through these problems, okay? Just A, B, C, and D for number 1 and number 2. That's your goal. If you need help, ask the sub for help, and you may go ahead and work on these for the rest of class. Once you're finished, you may move on and check your answer. But it's not enough that you have the answers, because I gave you the answers, right? You see the answers are there? Doesn't matter that you have the correct answers. What matters is that you show the work. You can't get credit for this unless you show the work. Like, I need to be able to see this work. You see? If I don't see your work, you won't get credit because I gave you the answers. So I don't care if you have the answers or not. You could have just copied them for all I know. What I need to see is the work. That's what you're just going to give you credit, okay? I need to see that you looked for the scale factor through division, and then you found the x by multiplying it back. Okay? All right. So make sure you complete at least number 1 and number 2, A through D. And if you finish, you may move on to 3 and 4. That's it for today.